Algebra 1, lesson 2.2. So we just went over the vocabulary and now we're going to jump into the lesson. So if you're following along online, this is page 2 of the online book in module 2. So lesson 2.2. First thing we want to talk about is how to solve equations. So there's some basic principles that we need to know about solving equations. Here we're asked to solve for x, and we have the equation. Remember, it's an equation because it has an equal sign. This is an expression, and this is an expression. Two expressions equal to each other is an equation. So we're asked to undo what is being done to the variable by doing the opposite function, and it's reverse PEMDAS. If you remember PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction in the order in which they appear. When we are solving a math problem, such as 5 times 3 plus 2 minus 5 squared times 7, divided by 3. Okay, you start with anything in parentheses. Okay, we don't have anything, so then you move down to the exponents right here, and then multiplication and division, and then addition and subtraction. So you would go in the downwards order, start here and move downwards. However, when you're solving an equation, we have to undo things. So we have to go in the opposite. We're always doing the opposite. When you're doing algebra or solving for a variable, letters, they seem opposite, don't they? So we're always going to do things opposite. So that means we're going to have to go in the order, an upwards order. We're going to start undoing the addition and subtraction before we start undoing multiplication, division, exponents, or parentheses. Okay, so here we're going to undo what's being done to the variable. Here's clearing. All right, so I need to identify where my variable is. It's right here. So if I'm going to undo PEMDAS, I need to start by undoing any addition and subtraction first. So that means I want to undo right here my plus 7 first. So how do I undo a plus or an addition problem? I'm going to subtract 7 from both sides. And so that means I'm going to be left with negative 3x equals 9. Okay. All right. So there's no other addition and subtraction. That's done. Now I need to move to multiplication and division. Is there any multiplication or division for me to undo? Well, I have negative 3 times x. So I need to undo this times, or this multiplication here. So in order to undo multiplication, I'm going to do the opposite of it. Negative 3x divided by negative 3 on both sides. This is going to cancel out, and I'm left with x equals 9 divided by negative 3 is negative 3. And so after I undo everything, the value of x just reveals itself to me. I didn't have to do anything to figure it out except undo what's already been done to it, because it wants us to know what its value is. It wants to be fully known, as it were. All right, so let's move on. What happens if you have variables on both sides of the equations? So here we have 5, the first expression is 5x plus 3, and the second equation, or expression rather, is instead of a single number, is something with a variable in it as well, negative 3x plus 5. What do? Well, this is very similar to the last one, but just a tinge different. We want to start by getting all of our variables to the left side, all of our terms of variables to the left side, and all of our terms without variables to the right side. So that's the first step in this. So I'm going to identify any variables I have on the right side. And again, this is when I like to use these different colors, because I'm going to do that one in green, and I'm going to say, okay, well, here's a constant I want to move to this side in red. Okay. Now, as you switch sides, you're going to switch the signs. Remember, signs are usually we see them as operations. Right here, it looks like an operation of plus, right? But this can also double as a sign, a positive sign. Here we have a negative sign. So when we switch this positive 3 to the right side, it's going to become a negative 3. Okay, so I want to start writing this equation with the information that I have beginning. I have 5x. That didn't move. Okay, and I've got 15 here. That didn't move. And I've got my equal sign. That didn't move. So I left all of the things that didn't move. I went ahead and wrote those down first. Now, I'm going to move my negative 3x from the right to the left. So it changes from a negative. If it switches sides, it's going to switch signs. Moving it from the right to the left. So it's going to change from a negative to a positive 3x. Okay. Now, my plus 3 over here on the left, I'm going to move all my constants from the left to the right. And if it switches sides, it's going to switch signs. This is a positive 3. So I'm going to change it to a negative 3. Well, I can't just have negative 3 next to 15. So I have to remember 15 had a plus in front of it. That didn't change. It was a plus, a positive 15. It never changed sides. So that's going to stay the same. All right, now we just continue working from here. I have like terms, so I'm going to combine these. So 5 and 3, the x stays the same. I'm going to combine the coefficients. 5 plus 3, 5, 6, 7, 8, 8x equals. Okay, then here I've got a negative 3 and a positive 15. I have different signs, so I'm going to find the difference. 15 minus 3 is going to be 12. My answer will take on the sign of the greater value. 15 has got a greater value than 3, so my sign is going to be positive here. Okay, and then I have to undo the, now I start undoing PEMDAS. Let x reveal itself. So only thing I have left to undo is to undo the multiplication. So I have x being multiplied by 8, so I have to divide by 8 on both sides. This one's going to cancel out. I'm left here with x equals, well, 12 divided by 8, it doesn't give me a nice round, even integer whole number, right? So instead, I'm going to reduce. If I reduce both of these by 2, I get 6 and I get 4. Well, I can reduce those again. That becomes 3 and 2. So usually when you're answering math problems, most math teachers today prefer a reduced fraction as opposed to a decimal, and they prefer a improper fraction as opposed to a mixed number. So 3/2 is usually going to be the appropriate answer, but always check your instructions to see how the teacher or the instructions on the sheet asks for the answer to be input, because it could be in a decimal format. So you always, no matter the class, whether it's math or anything else, need to read your instructions. All right, so equations with parentheses. In this case, before you can start solving, one of the best things to do is to distribute. We see a 7 times the things in parentheses. So there's 2 ways to handle this. You can distribute, like I was just talking about, or if it's easy to just divide by 7, you could do that as well. But you have to remember, when you have different terms like this, dividing by 7 isn't, you can't just choose one and say, okay, I'm going to divide by 7. When you divide by 7, you have to divide every single term by 7. And this one would cancel out. And right here, the 7s we'd still have a negative x, but these other ones would be fractions. And fractions are a little harder for me to work with, so I'm going to choose to distribute this instead of dividing first. So what I'm going to end up with is negative 7x minus 4 minus 2x equals 7x plus 7 times 4 is 28. Okay, now I'm back to what I started with before, where I just have some variables on both sides. So I'm going to identify what each of these are. I know I want to move my 7x to that side, right? And then I have a constant over here. I have a negative 4 that I want to move to that side. All right. So let me go ahead and write down the ones that didn't move. I've got negative 7x, that's going to stay on this side. I've got negative 2x, that's going to stay on this side. My equal sign is going to stay right there. And my positive 28 will stay in its spot as well. I have a red pen in my hand, so I'm going to start with the constant this time. Negative 4, I want to move from the left side to the right side. And if it changes sides, if it crosses this equal sign, it has to change signs. So it's going to become a positive 4. I do not need to put a positive sign in front of it. It is implied. All right, so now let's pick up the green pen. We're going to move 7x from the right to the left. So when I do that, when I switch sides, I have to switch signs. Right now, my 7x is positive. So on this side, I'm going to have to write it as a negative 7x. Okay. So then we continue on as normal. We're going to combine like terms. I have 3 terms that all have the term x. It's the same letter and the same exponent. So I'm going to write down here x. That doesn't change. And then I need to combine all my coefficients. Negative 7, negative 2, and negative 7. They're all the same sign. So I'm going to combine. 7 plus 7 is 14 plus 2 is 16. And then they keep the sign that all of them have. So negative 16x equals my constants, 28 plus 4. That's easy enough. 28, 29, 30, 31, 32. Remember, you can always use a calculator. Check your work. Even if you're just adding 1 to something, it's beneficial, especially on graded assignments, quizzes, and tests, to always use your calculator and check your work. Don't trust your head tells you whether or not your answer is going to make sense. I want you to use your head. I want you to think of an answer, but verify it with the calculator. Okay. So here we have negative 16x equals 32, and that is multiplication. So in order to undo the multiplication, we do division, dividing by negative 16. Okay, so that's going to cancel out, and we're left with just an x. 32 divided by 16 is 2. Since there's an odd number of negative symbols, I'm going to have a negative there. X equals negative 2. Oops, let me clear this drawing. All right, so that brings us to some real world examples. Most of us have cell phones, right? Well, there is, with cell phones, you can have unlimited plans if you have a good plan. If you have a plan that costs you less per month, then you may only have a limited amount of data that you can use, and then you have to pay for anything over that. Here's an example of that. This person pays $40 per month, no matter what, and they get 5 gigabytes of data for that. Last month, we went over our phone by 35 megabytes and we're charged 50 cents per megabyte. If you notice, this number right here is kind of extra information. I don't want to get confused and think I need to put that in my equation at all, because I'm not being asked how much data I used, so I don't need to know this information. It's unnecessary. So I cross it out to get it out of my mind. The question is, how much do I owe? Well, I know I owe $40, and then I also owe, which means I'm going to add to my bill, right? Not subtract from it. I'm not getting a discount. I'm adding to my bill. I owe my $40 plus how much I owe for going 35 megabytes over at 50 cents per megabyte. So plus 35 times 0.5, or 1/2. So another way to write this would be 1/2 35 plus 40. Okay, so half of 35, 15, 17 and a half. So we've got 17.5 plus 40. 4 and 1 is 5, so that's 57.5. So $57.50 is how much this person owes for their cell phone bill that month. We started with the constant of 40. Okay, that's what it was. But if we don't know how much the person goes over their general bill, well, I think actually that is in this next section here. Next question. If our bill was $60 last month, how much extra did I use? Well, if we think about this, every month we have to pay $40 plus 0.5 or 1/2 times X, X being how much we went over, right? So we have this general equation that tells us how much our bill is going to be every single month. If we stay under our 5 gigabytes of data, we don't go over our allowed amount, then we only have to pay $40 because you'd put a 0 in right here. 0 times 1/2 is 0. 40 plus 0 is 40. So your bill would only be $40 a month. But what if our bill is $60? How do we figure out how much we went over by? Well, we have to put this equal to 60. Okay, so our bill equaled $60. We know this is how we figure out how much the bill is. So now with that information, we can undo everything that's being done to X and figure out, let it reveal itself to us to tell us how many minutes we went over. Okay, so again, using PEMDAS, the first thing we want to undo is any addition or subtraction we see in there. Well, 1/2 X, the X right now has 40 being added to it. Okay, so in order to undo this, 40 is a positive. You always look at the symbol in front of it, not behind it. This positive matches with the 1/2. 40 is positive because there's no symbol in front of it. So we're going to subtract 40 from both sides. Okay, this one will cancel out, and I'm going to be left with 1/2 X equals 20. 60 minus 40 is 20. Okay, now fractions. All you have to think of is it's a division symbol. So when we go down PEMDAS, remember we're going back up this time, we just did the addition and subtraction. Our next one is going to be multiplication and division. The first thing we need to undo is any multiplication and division that's being done to this. So this is the same thing as 1 being multiplied by X and being divided by 2, because we could also write this as 1X over 2. So X is being divided by 2. So how do we undo division? Well, we can multiply by 2. Okay, so that's going to leave us with 1X equals 40. Okay, how do you undo the 1? You're going to divide by 1. I didn't want to not include it in case you do have a fraction in which it's a number other than 1 up here. You do want to keep that there. But since it's a 1, we can just have it math. Remember, certain numbers can disappear, and 1 is one of those numbers that just disappears a lot. So X equals 40. So if our bill was $60, we used 40 extra megabytes. All right, so I want you to think back to our last unit where we talked about consecutive numbers. Here you have 3 consecutive integers that have a sum of 171. Here you have a rectangle that's longer on one side than it is wide. These should be review questions to you. Go ahead and pause, complete the work, and come back and we'll go through them. All right, welcome back. We have 3 consecutive integers that have a sum of $171. I'm sorry, 171. I'm still thinking of the cell phone bill. All right, so let's think of the numbers. Our first number, I'm going to put N for number, okay? I don't know what it is, so I'm going to use a variable to think about it. Well, my second integer is 1 greater than that, so N plus 1. Okay, and my third integer is going to be 2 greater than this first one, N plus 2. Well, if I add all these up, instead of having these commas to separate each of them, I want to add them all. So N plus 1 plus N plus 2 is going to equal 171. I still have my 3 numbers here, N, N plus 1, and N plus 2, right? So how do we solve this? Well, the first thing we have to do is combine like terms. I see 1, 2, 3 like terms. Their coefficients all happen to be an implied number 1. So I'm going to combine all these coefficients. I have to first write my variable of n, combine 1, 1, and 1. 1 plus 1 plus 1 is 3. I want to cross them out so I remember that I did them already. Okay. And then I've got here a positive 2 and a positive 1 constant. I want to combine those. Those are like terms as well. So positive 2 and positive 1 make a positive 3 equals 171. Now, using the opposite of PEMDAS, right? I want to go up. So I first need to undo my addition and subtraction. I have a plus 3 here. So I'm going to subtract 3 from both sides. That leaves me with 3n equals, what's 171 minus 3? Well, if I subtracted 1, it's 170. Subtract 2 more is going to be 168. Use your calculators just to double check that. And then you have 168. You need to undo this multiplication that's being done to the end. So we're going to divide by 3. So 168 divided by 3 is 56. N equals 56. All right. I'm going to choose a different color here for this one. A rectangle is 12 meters longer than it is wide. I'm going to draw my rectangle up here, but I'm drawing it in green so you know that it's associated with this second problem here instead of the first problem. It's 12 meters longer than it is wide. So I'm going to put for the width just W. You could use X, you could use whatever, but its length right here is 12 meters longer. So I'm going to have W plus 12. Okay. Now it says the perimeter is 68 meters. Okay. Well, I know perimeter means I'm going to add it all up. So P equals. Okay. I'm going to add up these two sides that are just W. W plus W. Because this one's a W as well. And one thing we know about rectangles is that opposite sides are congruent or have the same measure. So W and W. That means that this one is W plus 12 because it's congruent to that one, right? W plus W. I added that one. I added that one. Need to add one more. W plus 12. That's this side. Okay. And I have one side left. I need to add up W plus 12. Okay. Anytime you have a perimeter, it just means add every single side together and then you'll know the perimeter. So I'm going to add my like terms. I've got 1, 2, 3, 4 W's here with a coefficient of 1. So what I'm going to do is go ahead and write my W and add my coefficients. 1, 2, 3, 4, added them all together and I get 4. 1 plus 1 plus 1 plus 1 is 4. Okay. I'm going to cross those out so I know I've already used them. And then I've got my constant of plus 12 and plus 12 here. So that when I combine them is going to become 24. P equals 4W plus 24. Now it tells us that the perimeter is 68. So what I can do here is the perimeter of 68, I can plug into where this P is, right? And because I know what the perimeter is. And now I'm able to find the width. I created a problem that told me, I created a math sentence rather, that told me what the perimeter was. And then I filled in, I already know what the perimeter is. So now I'm able to use all of the information that I know to find the width. And using my PEMDAS here, remember, I want to go up. I have to undo addition and subtraction first. So the variable has 24 being added to it. So I need to subtract 24 from both sides. So I'm going to have 4W. And it's going to be equal to 68 minus 24. 6 minus 2 is 4. 8 minus 4 is 4. And I flipped this around. As long as both of them flip around, that's fine. You can switch the variables to the opposite side as long as the other expression flips sides as well. So here you have to undo the multiplication that's being done to W. 4 times W equals 44. So we're going to undo that multiplication with division. So we're going to divide by 4 here. And that's going to give us W equals 11. Okay. Hopefully you all got the exact same answers I did. All right. Now your turn. The sum of 52 and 5 less than 3 times the number is 71. So you're supposed to find the number. Go ahead and pause it. You can do all three of those, then come back and we'll go over the answers. All right, welcome back. The sum of 52 and 5 less than 3 times a number. That's a lot of words. Let's make a math sentence. That's a lot more easier to understand. So we have is 71. I'm just going to write that because I know what that is. All right, the sum of 52 and, so 52 plus 52 and the sum. Okay, 5 less than 3 times a number. Well, I know 5 less. I'm going to put that at the end. Okay, 5 less than 3 times a number, 3 times a number. Okay, let me put these, this is kind of spread out. So I'm going to put this down here on the bottom. The sum of 52 and 3. So the two things I'm adding together is 5 less than 3 times a number and 52. So I'm going to have 52 plus 3n minus 5 equals 71. Because I'm adding two things, the sum of 52 and this. All right. Now, does my having the parentheses around this change this equation at all? Well, if we distribute the plus sign to everything in here, it's going to stay exactly the same. So there's no need for me to have the parentheses around this. We can just go ahead and drop that. But it's important when you first write it to write it exactly as it's written and then determine whether or not you still need those parentheses. Because if it was the difference of 52 and, you would definitely need those parentheses because that minus sign in front of it would definitely change it. So you have to always write it as it says in English and then determine whether or not you need the parentheses. All right, so I want to combine like terms. I only see one thing with a variable here, so that's going to stay exactly the same. However, I see two constants. I see a positive 52 and a negative 5. So that's going to come to a positive 52. 52 minus 5 is going to be 47. Yeah, 47 equals 71. Let me just verify on my calculator that that's what it is. 52 minus 5 is 46. Okay, this is why you want to make sure you use your calculator. 52 minus 5 is 47. I typed it into my calculator wrong. All right, I'm going to double check it a third time just to be sure, because with math, you can always have a simple error that gets you a wrong problem, but it's easy enough to avoid by checking your work. So 52 minus 5 equals 47. Okay. All right, I got it down. I got it right. Now, the opposite of PEMDAS, I'm going to start undoing any addition and subtraction first. I have a plus 47 on here. I want to subtract 47 from both sides. So I'm going to use my calculator here from the get-go. 71 minus 47 equals 24. So 3n equals 24. What's being done to the n? Multiplication of 3. So now we need to divide by 3 to undo it. 24 divided by 3 is going to be 8. So n equals 8. All right, let's change here to another color, green. The lengths of a triangle are consecutive odd integers. So the first thing I want to do is draw a triangle. They're consecutive. So n, and then one greater than that, and one greater than that. But consecutive odd. So that means if n is 1, then this one is going to be 2 greater than that, 3, right? N plus 2. And then this one down here, if it was 1, 3, and 5, 5 is 4 greater than our original n. So instead of doing n plus 1 and n plus 2, because we have the specification here of odd integers, I know that it increases by 2 every time. So I'm going to do n plus 2, and n plus 4. Okay. And it tells me the perimeter of the triangle is 33. P equals 33. What is the length of the longest side? The longest side is going to be the side that's n plus 4. I want to keep that in mind when I go back after I figure out an equation here and solve it. I want to make sure that I'm actually answering that question. So let's see. I know perimeter is going to be when you add up all the sides. So my first side is n, okay, cross that out, plus my second side, n plus 2, plus my third side, n plus 4. So that's my perimeter. And then I know that my perimeter, I don't need to put a P in there because I know what my perimeter is. It's 33. So now I'm going to combine my like terms. I have 1, 2, 3 like terms. So I'm going to put an n right here. Add their coefficients. That's the coefficient of 1 plus 1 plus 1 is 3. Okay, now I'm going to cross those out because I knew I already did them. Combine my constants. 4 plus 2 is going to be 6. So I've got 33 equals 3n plus 6. Undo the plus 6 by subtracting 6. I'm going to get 20, I think it's 27. Let's see, 33 minus 6 is 27. 27 equals 3n. And then we're going to divide by 3 to undo this multiplication of 3 right here. And we're going to be left with n equals 9. Now, this is a word problem. Up here, I shouldn't have left it as n equals 8. I should have written the number is 8 because it's a word problem. I should have a word answer. So here I have a word problem. I need a word answer. My question I'm looking for is what is the length of the longest side? Well, n is the shortest side. The longest side is going to be n plus 4. So to find the longest side, I'm going to have to add 4 to this 9. So my answer is going to be the longest side is, well, 9 plus 4 is 13. What is my unit of measure? Inches. So the longest side is 13 inches long. All right. Moving on here to this last one. I want to distribute this. I'm going to get 3x minus 12 equals 7x plus 10. Now I want to move some of these to different sides. I want to move my variable from the right to the left. Okay. And I'm going to move my constant from the left to the right. Okay. So let me rewrite the things that are staying where they are, that aren't moving. I'm going to start with this 3x that doesn't move. Okay. Cross that out. I'm going to leave a space here in the middle. And I've got my equal sign, leave a space. I'm going to do plus 10. Okay. So those are the things that did not move. Now, look at this yellow right here. Minus 12 needs to move sides. When you change sides, you want to change signs. So it's going to become a positive 12. I do not need to write the positive. It's implied. Okay. The 7x is going to change sides. So it has to change signs. It's currently positive. So I'm going to put a negative 7x on this side. All right. Now, I want to combine like terms. I have x and x here. So that's going to make an x. We do not change the variable when we combine like terms. Nothing changes about the variable. It's the same letter and the same exponent no matter what, before and after here. What does change is our coefficient, the numbers before the variable, okay? So my negative 7 and my positive 3, I want to combine those. And they're different signs, so I need to find the difference. 7 minus 3 is going to be 4. 4, 5, 6, 7. Now, I know it's going to be a 4, but what is my sign before the 4? Is it positive or negative? Well, I look at the values that I started with and see which one's bigger. Well, 7 is the bigger value, and it has a negative sign, so my answer is going to use that. Okay, so negative 4x equals 12 plus 10 is 22. Now to undo the -4 that's being multiplied by the x, we have to then divide both sides by -4. 22 divided by -4 is going to be -5.5 or -5.5. And you could reduce that down to a fraction, a reduced fraction, depending on what your instructions are. We don't have any instructions here, so I'm just going to go with the decimal. And that was all of our practice, all of our work for this lesson, page 2 in module 2. And I will see you back momentarily for page 3.